Okay, hi everyone. So as promised, I wanted to go over question number 3 with you and highlight the algebraic mistakes that I saw kind of across the board, and also talk about ways and places where number sense has got to be a tool that you use, okay? So here is the question for question number 3. And what I highlighted here was something that many of you neglected in your work. So part A, find the x-coordinate that corresponds to the absolute minimum value of f of x. Okay, and that's going to be important. Show the analysis that leads to your conclusion. So the first thing I did here was I found f prime of x, and this is where many of you lost your way. In the course of finding where f prime of x will equal 0, right, many of you kind of got stumped here. And you neglected to say, well, perhaps I can describe f prime in factored form. So factor out 3x, that leaves you with a quadratic degree 2 trinomial, and then it allows me to factor right here. Okay, so I write down f prime equals 0 at x equals 0, 7/4, and negative 2, and of course negative 2 we disregard because negative 2 is not in this restricted domain. Down below here is my first derivative sign analysis. Okay, now if you look at this interval, it is inclusive of negative 1 and 3. F increases, then decreases, then increases. 7/4 is the location of a min, but here's the thing, so is negative 1, because negative 1 is an endpoint, and if you think about the graph of f, if f starts to increase at x equals negative 1, it's going to start going, boom, in that direction. That means at this endpoint, there is a min. Now, whether it's an absolute min or a relative min, that begs to be determined. This question is asking you for an absolute min, so the question becomes, how do I compare, how do I figure out between these two x values, which one is an absolute min? Come over here. I have to plug in x equals negative 1 and x equals 7/4 back into the function. Here is the function. And again, because I have to plug x into this, negative 1 isn't that big of a deal. When it gets to 7/4, it's going to be a mess. I took f of x, I expressed it in factored form, just factoring the x squared out, which in the case for negative 1 isn't that big of a deal, right? Because that was easy. But what happens when x equals 7/4 and I'm plugging into f of x? One more time, I'm using this version of f of x to make my life easier. Here's what I did, everyone. Look, this is x squared because, let me see if I can shrink it a little bit. Yep, okay, see, I'm using, right, this version of f of x to plug in right here. Okay, and this is where some number sense is going to be to our advantage. I saw some of you make the most impressive holy messes, and it really didn't need to be. Look what happened. 7/4 squared is 49/16. 49/16 is very, very close to 3, okay? And unless these two y values are very, very close, all I need to do is get to a point where I can definitively say one of these y values is less than the other. Here you'll see me do this, everyone, watch. I just kind of went and did, let's see, fraction 1 and fraction 2, found a common denominator, and then I'm right here. Okay? Now if I look at this for a second, 175/16, let's just think about this. 175/16 is, let's say, maybe, if I made this, if I look at 175/16 minus 21, I'm inclined to say that this whole number here is really close to negative 10. Why? Well, let's see. 175/16 versus 160/16, right? 160/16 equals 10, right? 10 minus 21, that would make this parenthesis negative 11. Okay, and if this, where am I going with this? Okay, if this number were 170/16, this whole thing would equal negative 10. You understand? But the fact that it's 175/16, no wait, hold on a second. One more time. If this number were 160 over 16th, this would be 10 minus 21, making this negative 11, right? The fact that it's 175 sixteenths means that this number here is going to actually be bigger than negative 11. So at the end of the day, if I look at this, negative 10 times 3, the whole thing is going to equal about negative 30, which I already know is less than negative 19. This is just using some number sense. So here, for part A, the absolute min must occur at x equals 7/4. Right? Just some number sense. There should never be complete vomit, but you use a little bit of number sense here. Okay? The second question is, find the intervals of x over which f of x is concave down. All right? Here's me taking the second derivative. Here we are down here. Second deriv. Once again, factored out to 6. This is a quadratic trinomial, which is now factorable. F double equals 0 at x equals 1, x equals negative 6. This, of course, is out of my domain of negative 1 to negative 3. And here is my second derivative sign analysis. And now I can see that f is concave down on the interval x equals to negative 1 to 1, because intervals of concavity are always not inclusive. Okay? Now, I hope this sheds some light on the use of algebra, how algebra really is your best friend. There's a really famous saying in calculus, which is the hardest part of calculus is the algebra, and it's remembering how algebra can help you. Some number sense over here is the important takeaway. For 7/4, yes, this was a deliberate question to see who could kind of just think their way through this and make their life easier for themselves. I'd like to give these as homework questions. Here are 2 optimization questions, one over an inclusive closed interval, which is what this is, and then this one is over an infinite open interval, so negative infinity to positive infinity, and then 2 applied optimization questions. Okay, so for homework, when I see you on Wednesday, you will have had L'Hopital's with the indeterminate forms 0 over 0, positive negative infinity over positive negative infinity, and 0 times a form of infinity, right? We know now how to deal with indeterminate forms of these type, and we're just going to fortify and strengthen our work with applied optimization and I guess curve analysis. Okay? Thanks everyone.